we discuss system of circles topic. Now in this topic we get at least 2 to 3 marks in Eamcet. Now system of circles. System of circles is nothing but 2 or more circles. If suppose 2 circles are there, one circle completely lies outside of the circle. Now if suppose center of the first circle C1, center of the second circle C2, radius of the first circle R1, radius of the second circle R2. Now C1, C2 are centers of 2 circles, R1, R2 are their radii. Now C1, C2, if C1, C2, C1, C2 nothing but distance between centers. Distance between centers is greater than sum of radii. Distance between centers greater than sum of radii, then one of the circle completely lies outside of the second. One of the circle completely lies outside of the second. Now these circles having 4 common tangents. These circles having 4 common tangents. Now in that 2 are called direct common tangents, other 2 are transverse common tangents. Now direct common tangent means if suppose the centers of 2 circles, lie on the same side of the common tangent, then that common tangent is called direct common tangent. Now these 2 are direct common tangents. Direct common tangent DCT. Now if suppose the centers of 2 circles lie either of the side, lie opposite sides of a common tangent, then that common tangent is called transverse common tangent. Transverse common tangent. Now the point of intersection of direct common tangents, the point of intersection of direct common tangent is called external center of similitude. Center of similitude. Similarly, the point of intersection of transverse common tangents is called internal center of similitude. Now, always external center of similitude divides C1, C2 in the ratio R1 is to R2 externally. The external center of similitude divides C1, C2 in the ratio R1 is to R2 externally, and the internal center of similitude divides in the same ratio R1 is to R2 internally. Now, internal center of similitude divides C1, C2 in the ratio R1 is to R2 internally. Now, always C1 internal center of similitude, C2 and external center of similitude. The 4 points lie on a straight line or collinear, lie on a same straight line or collinear. Now internal center of similitude divides C1, C2 in the ratio R1 is to R2 internally. Similarly, external center of similitude divides C1, C2 in the same ratio R1 is to R2 externally. Then internal center of similitude and external center of similitude are harmonic conjugates to each other with respect to the line segment C1, C2. With respect to the line segment C1, C2. Internal center of similitude and external center of similitude are harmonic conjugates to each other with respect to the line segment C1, C2. If suppose C1, C2 equals to R1 plus R2, R1 plus R2, in that case the 2 circles touch externally. If distance between centers of 2 circles equals to sum of radii R1 plus R2, distance between centers C1, C2 equals to R1 plus R2, then the 2 circles touch externally. In that case, we get only 3 common tangents. In that 2 are direct common tangents, only one is transverse common tangent. 2 are direct common tangents, one is transverse common tangent. If suppose the difference of radii less than C1, C2 is less than sum of radii, or distance between centers lies between difference of radii and sum of radii, in that case the 2 circles intersect each other. Now these circles having only two common tangents. Now these two common tangents both are direct common tangents. Direct common tangents. If suppose difference of radii equals to distance between centers, in that case the circles touch internally. The circles touch internally. If suppose C1, C2, R1, it is R2. Now difference of R1 minus R2 equals to C1, C2. In that case, the circles touch internally. The circles touch internally. Now these circles having only one common tangent. These circles having only one common tangent, that is a direct common tangent. Direct common tangent. Because the centers of two circles lie only one side, same side of the common tangent, then that is only direct common tangent. If suppose the difference of radii is greater than distance between centers, in that case one of the circle completely lies inside of the second. One of the circle completely lies inside of the second. Now no common tangents for these circles. If suppose R1 not equals to R2 and C1, C2 equals to 0, distance between centers equals to 0, in that case the circles are concentric, both having same center. Distance between centers 0. 0 means first circle and second circle both having same center, but radius of the first circle not equals to radius of the second circle. Now the two circles are concentric circles. For these circles also no common tangents. No common tangents. If suppose two circles, they are intersecting circles, one of their point of intersection P. P be the point of intersection of two circles. At the point P, tangents are drawn to the circles. If angle between the tangents is theta, angle between these tangents is theta, then theta is called angle between the circles. Theta is called angle between the circles. If R1, R2 are radii of two circles, d is the distance between their centers, and angle between the circles theta, then cos theta equals to d square minus R1 square minus R2 square by 2 R1 R2. If R1, R2 are radii of two circles, d is the distance between their centers, and angle between the circles theta, then cos theta equals to d square minus R1 square minus R2 square by 2 R1 R2. If suppose the theta equals to 90 degrees, theta equals to 90, now cos 90 0, after that by cross multiplication we get d square equals to R1 square plus R2 square. If angle between the circles is 90 degrees, then the condition is d square equals to R1 square plus R2 square. If angle between the circles is 90 degrees, then the circles are called orthogonal circles. Orthogonal circles. If suppose the two circles, one is x square plus y square plus 2g1x plus 2f1y plus c1 equals to 0, another circle x square plus y square plus 2g2x plus 2f2y plus c2 equals to 0. These two circles orthogonal to each other, then the condition 2g1 g2 plus 2f1 f2 equals to c1 plus c2. Also d square equals to r1 square plus r2 square. By using the condition d square equals to r1 square plus r2 square, we get 2g1 g2 plus 2f1 f2 equals to c1 plus c2. Two circles orthogonal to each other, condition 2g1 g2 plus 2f1 f2 equals to c1 plus c2. If suppose the two circles, one circle s equals to 0, second circle s dash equals to 0, p be any point, p be the any point, or p x1 by 1. Now the power of the point p with respect to the first circle is s11. Similarly, the power of the point p with respect to the second circle s dash 11. If suppose the powers of the point p with respect to the two circles are equal, then the locus of the point P x1 y1, the locus of the point P x1 y1 is called radical axis of the circles. Radical axis of the circles. Now the locus of the point P, for which the powers of the point P with respect to the two circles are equal, then that locus is called radical axis of the circles. That locus is called radical axis. Now radical axis is a straight line. If suppose C1, C2 are centers of two circles, now radical axis, always radical axis of the circles perpendicular to their line of centers. Radical axis perpendicular to line of centers of the circles. Now from any point on the radical axis, the lengths of the tangents are equal. The lengths of the tangents are equal, and also radical axis perpendicular to the line segment joining centers of the circles. Next, if suppose three circles, one circle S equals to 0, second circle S dash equals to 0, third circle S double dash equals to 0. Now it is radical axis of S equals to 0 and S dash equals to 0. S dash equals to 0. Similarly, it is radical axis of S dash equals to 0 and S double dash equals to 0. Similarly, the radical axis of next to two circles, radical axis of S equals to 0 and S double dash equals to 0. Now, these three radical axes concurrent at one point are passing through one point. Now, that point is called, the point of concurrency of radical axis is called radical center. Radical center of the circles. Radical center of the three circles. Now, if suppose a circle, here the lengths of the tangents from radical center to the three circles are equal. The lengths of the tangents from radical center of the three circles to the three circles are equal. If suppose a circle orthogonal to the three circles, then the radical center of the three circles is center of orthogonal circle, and length of the tangent from radical center to any one of the circle is radius of the orthogonal circle. Next, we start problems. The circles x square plus y square minus 2x minus 4y plus 4 equals to 0, x square plus y square minus 4 equals to 0, x square plus y square plus 4x plus 4y plus 4 equals to 0, Options touch internally, touch externally, intersect at 2 points, or such that one completely lies inside of the other. Now, center of the first circle C1 equals to 1, 2. Center of the second circle C2 equals to minus 2, minus 2. Now, minus half of the coefficient of x minus half of the coefficient of y is center. Now, radius of the first circle R1 equals to square root of 1 plus 4 minus half minus plus 4, that equals to 3. R2 equals to radius of the second circle square root of 4 plus 4 minus 4, or that equals to 2. Now, distance between centers C1, C2 equals to distance between centers of two circles equals to square root of 1 plus 2 whole square plus 2 plus 2 whole square, or that equals to 5, equals to R1 plus R2. Now, distance between centers equals to sum of radii, then the two circles touch externally. Second option, the circles x square plus y square minus 2 lx plus g equals to 0, and x square plus y square plus 2 my minus g equals to 0. Touch internally, touch externally, like that options given. If suppose the two circles are orthogonal to each other, the condition 2g1 g2 plus 2 f1 f2 equals to C1 plus C2. Now 2 into G1 nothing but half of the coefficient of x in the first equation, half of the coefficient of x in the first circle equation, half of the coefficient equals to minus L, because the coefficient of x in the first equation minus 2L, half of the coefficient equals to minus L. Next to G2 equals to, there is no x term in the second equation, now G2 equals to 0, plus 2 into F1 equals to, there is no y term in the first equation, 0, F2 equals to M, half of the coefficient of y, equals to C1 plus C2, C1 equals to plus G, C2 equals to minus G, G minus G. Now both sides 0 equals to 0, then the two circles are orthogonal to each other, orthogonal to each other. Third option is correct. The circles x square plus y square minus 4x plus 6y plus 8 equals to 0, x square plus y square minus 10x minus 6y plus 14 equals to 0 touch each other, then the point of contact is, the point of contact, if suppose the two circles touch each other, they may touch externally, otherwise internally. The two circles may touch externally or internally. Now the equation of the common tangent at their point of contact, equation of the common tangent at their point of contact is s minus s dash equals to 0, s minus s dash equals to 0. From one circle equation subtracting second equation, we get equation of the common tangent at their point of contact, at their point of contact. Now equation of the common tangent, s minus s dash, first circle consider s equals to 0, second s dash equals to 0, then equation of the common tangent at their point of contact, 6x plus 12y minus 6 equals to 0, or x plus 2y minus 1 equals to 0, x plus 2y minus 1 equals to 0. Now after that, the point of contact, it is foot of the perpendicular of center of any one of the circle on the common tangent, foot of the perpendicular of center of any one of the circle, foot of the perpendicular of center. Now center of the first circle 2 comma minus 3. Now just finding foot of the perpendicular of 2 comma minus 3 on this line, we get point of contact, that is nothing but x minus 2 by 1 equals to y plus 3 by 2 equals to minus of 2 minus 6 minus 1 by a square plus b square, 1 plus 4. Now further simplifying, we get x equals to 3, y equals to minus 1, then point of contact is 3 comma minus 1, point of contact is 3 comma minus 1. The condition that the circles x square plus y square plus 2g1x plus 2f1y equals to 0, x square plus y square plus 2g2x plus 2f2y equals to 0 may touch each other, may touch each other. Now require the condition, the circles touch each other, they may touch externally or internally, the two circles may touch externally or internally. Now they having only one common tangent at their point of contact, at their point of contact, but in first circle equation there is no constant, there is no constant, then first circle always passes through origin, always passes through origin. In second circle equation also there is no constant, then second circle also passing through origin. Now two circles touch each other, they having only one common point, but both circles passing through origin, then compulsory point of contact must be origin, point of contact is origin. Now equation of the tangent to the first circle at origin, equation of the tangent to the first circle at origin, if first circle equation s equals to 0, equation of the tangent s1 equals to 0. Now we get g1x plus f1y equals to 0. Now the two circles may touch externally or internally, and point of contact is origin, and equation of the tangent at origin to the first circle S1 equals 0, that is nothing but G1x plus F1y equals 0. Similarly, the equation of the tangent to the second circle at origin is G2x plus F2y equals 0. G2x plus F2y equals 0. At the point of contact, the tangents are coincide with each other, or they represents only one line. Now, two linear equations represents only one line, then coefficients are in same proportion. Then G1 by G2 equals to F1 by F2. By cross multiplication, G1 F2 equals to G2 F1. Now it is the required condition. G1 F2 equals to G2 F1, second option. The equation of the circle whose radius phi, and which touches the circle x square plus y square minus 2x minus 4y minus 20 equals to 0, at the point phi comma phi. Now required equation of the circle whose radius of the circle phi, but that circle touches the given circle at phi comma phi. Now the radius of the given circle, its center is 1 comma 2, and radius equals to square root of 1 plus 4 minus of minus plus 20, or that equals to root 25 or 5. Now radius of the given circle phi, radius of the required circle also phi, but the two circles touch each other, then compulsory the two circles touch externally. If suppose the two circles touch internal, means both are coincident, or only one circle. Now the two circles are equal circles, because radius of the given circle phi, radius of the required circle also phi. The circles touch each other, compulsory the circles touch externally only. Required equation of the circle. Now center of the given circle C1 equals to 1 comma 2. The two circles touch at phi comma phi. Consider C2 center of the required circle. Radius of the given circle phi, radius of the required circle also phi. Then the point of contact is midpoint of C1 C2. The point of contact is midpoint of C1 C2, or line of centers, because radius of the first circle equals to same as radius of the second circle. Point of contact is midpoint of C1 C2. Now point of contact given phi comma phi, 1 comma 2 is center of the first circle, then center of the second circle we get 9 comma 8. Center of the required circle 9 comma 8, because phi comma phi is midpoint of C1 C2, then center of the required circle 9 comma 8. Now center 9 comma 8 and radius phi, the equation of the required circle is x minus 9 whole square plus y minus 8 whole square equals to 25. Now further simplifying, we get x square plus y square minus 18x minus 16y 81 plus 64 minus 25 plus 120 equals 0. The equation of the required circle x square plus y square minus 18x minus 16y plus 120 equals 0, first option. The angle at which the circles x square plus y square plus 8x minus 2y minus 9 equals 0, and x square plus y square minus 2x plus 8y minus 7 equals 0 intersect is. Now at center of the first circle C1 equals to minus 4 comma 1, center of the second circle C2 equals to 1 comma minus 4. Radius of the first circle R1 equals to square root of 16 plus 1 minus of minus plus 9, that equals to root 26. Radius of the second circle equals to square root of 1 plus 16 minus of minus plus 7, that equals to root 24. Radius of the second circle root 24. And distance between centers, d equals to distance between centers C1 C2 bar, or that equals to square root of minus 4 plus 1 whole square plus 1 minus of minus plus 4 whole square. Now 25 plus 25, that equals to root 50. Now r1 square plus r2 square, that equals to 26 plus 24 equals to 50, that equals to d square, because d equals to root 50. Now r1 square plus r2 square equals to d square, then angle between the circles is 90 degrees. Now pi by 2 is the answer. Fourth option. If x square plus y square minus 2x plus 3y plus k equals to 0, and x square plus y square plus 8x minus 6y minus 7 equals to 0, cut each other orthogonally, the value of k must be, now two circles cut each other orthogonally, condition is 2g1 g2 plus 2f1 f2 equals to c1 plus c2, 2g1 g2 plus 2f1 f2 equals to c1 plus c2. Now 2 into g1, half of the coefficient of x in the first equation, minus 1, g2 equals to half of the coefficient of x in the second, 4, plus 2 into f1 equals to half of the coefficient of y in the first equation, 3 by 2, into f2 equals to minus 3 equals to c1 plus c2, k minus 7. Now minus 8, 2 cancel, minus 9 equals to k minus 7. Now k equals to minus 10. The value of k equals to minus 10. Then first option is correct. First option. The circles of same radius a and centers 2, 3, 5, 6, 2, 3, 5, 6 cut orthogonally, then a equals to, now centers of two circles given and radius of the first circle a, radius of the second circle also a, because same radius a, and these two circles are orthogonal to each other, Now require the value of a, Now centers of two circles, consider c1 c2. Now distance between centers d equals to c1 c2 bar, or that equals to square root of 5 minus 2 whole square plus 6 minus 3 whole square, or that equals to root of 9 plus 9, 18. D equals to root 18. Distance between centers of two given circles equals to root 18. Now R1 equals to a, radius of the circle, first circle a, also radius of the second circle also a, because in problem given the same radius, the two circles having same radius, then R1 equals to a, R2 equals to a. The two circles are orthogonal to each other, or angle between the circles 90. Now d square equals to R1 square plus R2 square. Angle between the circles 90 degrees are orthogonal to each other. D square equals to R1 square plus R2 square. Here d square nothing but 18 equals to R1 square a square plus R2 square also a square. We get a equals to 3. The radius of the circle or a value is 3. Third option. If a circle passes through the point a comma b, and cuts the circle x square plus y square equals to k square, cuts the circle x square plus y square equals to k square orthogonally, the equation of locus of its center, Now a circle passes through the point a comma b and cuts the circle x square plus y square equals to k square orthogonally. The circle x square plus y square equals to k square orthogonally. Then required locus of center of the circle, locus of center of the circle. Consider x1 by 1 with the center of the circle, required locus of x1 by 1, locus of x1 by 1. Now it is considered c1 x1 by 1 and center of the given circle considered c2, that is nothing but origin, equals to origin. Now the distance between centers c1 c2 bar equals to square root of x1 square plus y1 square. It is nothing but d. D equals to square root of x1 square plus y1 square. Now the two circles are orthogonal to each other, then angle between the circles 90. Angle between the circles 90, condition d square equals to r1 square plus r2 square. D square equals to r1 square plus r2 square. Now here d square equals to x1 square plus y1 square equals to r1 square. Radius of the first circle equals to distance between center and any point on the circumference of the circle. Now that equals to x1 plus x1 minus a whole square plus y1 minus b whole square plus radius of the second circle equals to k. Now r2 square equals to k square, r2 square equals to k square. Now further simplifying, we get x1 square and y1 square get cancelled. 0 equals to minus 2a x1 plus a square minus 2b y1 plus b square plus k square. Now minus 2a x1 minus 2b y1, taking left side, we get 2a x1 plus 2b y1 equals to a square plus b square plus k square. Then locus of x1 y1 is 2ax plus 2by equals to a square plus b square plus k square. Now first option is the correct. The internal center of similitude of the circles x square plus y square plus 6x minus 2y plus 1 equals to 0, x square plus y square minus 2x minus 6y plus 9 equals to 0, plus 9 equals to 0 is. Now center of the first circle c1 equals to minus 3 comma 1. Center of the second circle c2 equals to 1 comma 3, 1 comma 3. Radius of the first circle r1 equals to square root of g square plus f square minus c, we get to 3. r2 equals to radius of the second circle 1. Now always internal center of similitude, divide the line segment c1 c2 in the ratio r1 is to r2 internally, in the ratio r1 is to r2 internally. Now internally dividing point mx2 plus nx1 means minus 3 into 1 minus 3 by 3 plus 1 comma 9 plus 1 by 3 plus 1. Now that equals to 0 comma 5 by 2. The internal center of similitude of the circles is 0 comma 5 by 2, third option. The external center of similitude of the circles x minus 2 whole square plus y minus 1 whole square equals to 9, x plus 3 whole square plus y minus 1 whole square equals to 4, equals to 4. Now center of the first circle c1 2 comma 1, center of the second circle minus 3 comma 1, r1 radius of the first circle 3, radius of the second circle 2. But external center of similitude, divide c1 c2 in the ratio r1 is to r2 externally. Now externally dividing point mx2 minus nx1 by m minus n, mx2 minus 9 minus 4 by 3 minus 1, 3 minus 2 comma 3 minus 2 by 3 minus 2, or that equals to minus 13 comma 1, minus 13 comma 1. Now first option is the correct. The radical axis of the circles x square plus y square minus 6x minus 4y minus 44 equals to 0 and x square plus y square minus 14x minus 5y minus 24 equals to 0. If suppose the two circles, one is S equals to 0, second S dash equals to 0. Now radical axis of two circles is S minus S dash equals to 0. S minus S dash. From first circle equation subtracting second, we get radical axis of the circles. S minus S dash. From first equation subtracting second, x square and y square terms get cancelled. Now 8x plus y minus 44 minus 24 minus 20 equals to 0. 8x plus y minus 20 equals to 0. Fourth option. Of the radical axis of the circles, x square plus y square plus 3x plus 4y minus 5 equals to 0 and x square plus y square minus 5x plus 5y minus 6 equals to 0. Now, the equation of radical axis S minus S dash, from first equation subtracting second, we get radical axis equation, that is nothing but 8x minus y plus 1 equals to 0. Now, required slope of the radical axis, slope equals to minus coefficient of x by coefficient of y, slope of the radical axis minus coefficient of x by coefficient of y, or that equals to 8. Fourth option. The centers of two circles are A, C and B, C, A, C, B, C, and their radical axis is y axis. Radical axis is y axis. The radius of one circle, one of the circle is r. Radius of one circle is r. Now, the radius of the other circle, required radius of the second circle. If suppose the radius of the second circle, consider r1. Now, center of the first circle A, C and its radius r units. Equation of the circle x minus a whole square plus y minus c whole square equals to r square. Similarly, center of the second circle B, C given, consider its radius r1, require the value of r1. Now, equation of the second circle x minus b whole square plus y minus c whole square equals to r1 square. Now, radical axis is nothing but from first equation, from one circle equation subtracting second circle equation, we get radical axis. Now, x minus a whole square minus of x minus b whole square equals to r square minus r1 square. But given radical axis of two circles is y axis, radical axis of two circles is y axis. Now, y axis equation x equals to 0. In this equation, at place of x equals to 0 substitute, we get a square minus b square equals to r square minus r1 square. Now, r1 square equals to r square minus a square plus b square. Now, radius of the circle r1 equals to square root of r square minus a square plus b square. Radius of the second circle is square root of r square minus a square plus b square. Third option.